Hello and welcome to today's Teardown session. I am your host, Helen Leigh, and today we've got a repeat guest, one of my faves, Aleksa from Thunderscope, and we'll be bringing him on shortly. But before we do, as usual, let's see what we've got going on at Crowd Supply this week. We've got lots going on this week, actually. Let's take a look. All right, so in 4 hours, this campaign is ending. It's been extremely successful. As you can see, it's Flippy Drive, a solderless optical drive emulator for the GameCube. This has been a very successful campaign, lovely human beings. And if you are interested in knowing more about this device, you can check out my live stream last week where I have the creators on answering questions in a very popular stream. Lovely folks. And if you want to support them, you've got 4 hours left to pledge. Also live at the moment is Zero Writer Ink, an open source e-paper typewriter. Lots of exciting things happening in the e-ink and e-paper field at the moment on Crowd Supply, this being one of them. Lovely little device. We've got one of the prototypes in the office and it's very cheerful. They've been successful already. They've got 14 days left and they've raised nearly 70K. So if you want to support them, please go on over. It looks like they've got some kind of giveaway going on as well. That's cool. And Joey Castillo, a regular on this stream, is doing his latest campaign, a Sensor Watch Pro. So you probably are familiar already with Joey's hack for the iconic Casio F91W. And this is a major upgrade. But the thing that I'm most excited about on this particular upgrade is Joey has gone out and gotten some really awesome custom LCD screens. So you can do all sorts of really awesome things with that. I have personally supported this campaign. I'm a big fan of this piece of hardware. Look at this, love a bit of flex. Delightful little hack. All right, so 35 days left there. He's just started and already passed his goal. Good job, Joey. Another one that's going pretty well with 35 days left is the Jumperless V5. This is from a hacker called Kevin Capuccio, a very fun guy. He was at the last Teardown, which is our annual hardware conference here in Portland, Oregon. And he did a very, very fun and popular workshop based on this. And there's a really fun, let's call it a software-defined breadboard. Why not? And they've got a fun little probe there as well. So this is a great little device. And if you're into that, go check that out. While I have, our next tab was there to remind me. So both Joey and Kevin and myself, actually, we'll all be at Hackaday Super Conference, and that happens at the beginning of November every year in sunny Pasadena, California. And I will be running, it's not up yet, but I will be running a stream from the conference and interviewing both of these folks who'll be there. So if you're on the West Coast or you fancy a trip to LA, do check out the Super Conference. There's a few tickets left. All right, back to stuff that we've got going on. There's this DeepRAD. We get a lot of cool SDR programs, devices on Crowd Supply, and this is one of them. It's an Android SDR RTL system. So if you want to support that, you can for the next 7 days. Oh yes, I wanted to highlight this. This just went live as well. This is a design challenge we've got going on at the moment with USB KVM. These are lovely folks with a great little device that was very popular on Crowd Supply. So if you are part of the USB KVM community, or you want to be, we have all sorts of fun prizes, and this is in collaboration with Make Magazine and Oshwa. You may have caught them on the Oshwa stream yesterday, but yeah, just wanted to highlight that we've got that competition going on as well. Finally, before I bring our guest on, I wanted to give a shout out to the sponsors of today's stream and of the program FPGA Playground, which is the program that Thunderscope is part of, which our guest is. So thank you very much, AMD. And here is the other one I wanted to do. The other thing that's crowdfunding at the moment is Thunderscope. It's doing super well, raised well over its goal with a mighty 35 days left. I've been excitedly watching this device come to life over the last few years, and I'm very pleased to stop talking myself and bring on the guy behind it. Let me just take this out and add Aleksa in. Hello, Aleksa. Welcome back. Thank you for joining us today. Would you like to introduce yourself to the lovely folks at home?
For sure. Yeah, I'm Aleksa. I'm the hardware designer behind Thunderscope. And yeah, it's a long time coming. Hopefully, just like last time, you will be able to stop me if I get on too much of a tangent. I did make my flight. I did do it.
You did. That's hilarious. So for those of you that didn't join us last time, I believe we went quite over last time as well. You've got two very chatty people on stream, and we ended up talking, and we were like, "Get off the stream! You're going to miss your flight." But you did make your flight. I'm very pleased to hear. That was a funny stream. So tell me, what have you been up to? Oh, actually, let's start with what is the Thunderscope. Let's start with a basic explanation of what it is, and then we'll tell you, and then we'll find out what you've been up to.
Yeah, so I'm going to tell you what I want it to be, and
okay,
you know, we'll talk about what it is, but really, what I want this to be is I want it to be the starting point of open source test equipment becoming the new kind of default option for your lab bench, right? Because it happened with 3D printers, right? We had RipRap, we had so many people build on that. And right, like, I'm not going to get into the discourse now, but it was really inspirational seeing that.
It
like,
was.
From when I very
yeah,
first started.
True. And it pushed it forward. It pushed the whole industry forward.
Exactly, right? Like, and it was something like, who would have thought it would be 3D printers? It was a niche piece of industrial equipment, right? And then people made the first thing happen, and it was good enough to use. And really, that's what I want to do and exceed, hopefully, with Thunderscope. I don't just want it to be usable, right? I want it to be the best scope for the money, right? Like, I want it to be the best, like, computer connected scope out there. And I really think, like, we will make it happen, right? Between the hardware, which has been, a labor of love for
it has
like 6 years now, right?
Really
You've seen me at all the conferences.
I have, yeah.
And this massive community effort, right? Like, we have so many, like, just incredibly cool and talented developers working on, like, not just stuff specifically for Thunderscope, but like entirely different projects that kind of have synergized with us. And yeah, it's incredible. And I think we have something potentially really big on our hands. And I want to do whatever it is in my power to do to continue this, right? So that it's not just Thunderscope, that there's going to be a thing after it, and a thing after it, and a thing after it. And maybe in 10 years, right? Like, it's not just going to be, oh, you have the Rigol or you have the Siglent, right? It's going to be, you have like a slew of open source options, right? Maybe something like a Voron where you build it yourself. Maybe, something like a Prusa where it's like, oh, like, that's a fully kitted out thing that is going to work, right? And who knows? Maybe there's going to be a bamboo equivalent as well. But it's a vibrant community.
I have both.
Exactly, right? But it's a vibrant community.
I feel disloyal
of 3D printing, and I want to see that happen for test equipment.
Thank you for that vision of Thunderscope. I would also like to narrow it down to, can we describe the hardware? What does it do?
Absolutely.
Just let's have some talk about functionality. Would it be unfair of me to describe it as a software-defined oscilloscope with an analog interface?
Pretty close. It is a software-defined oscilloscope in that it takes a lot of cues from software-defined radio, in that all the samples that you get from this thing, right, actually stream out to your computer via the like Thunderbolt / USB 4 interface, and then your computer does all the processing, right? And this of course uses PCIe at its core. So I've basically made it available as a PCIe card as well, right? Because it's essentially the same thing, right? You just either put it through the chipset that basically packages the PCIe through USB-C, or you just plug it into your desktop, and that's how that works. By streaming all the samples, you actually don't worry about sample memory anymore. Your computer's memory is sample memory, and that's a huge thing for oscilloscopes, because so many scopes, right? Like for years and years and years now, like 16 megabytes was like, wow, that's a lot of sample memory, right? And only recently have you been getting like, 100 megabytes, 200 megabytes. And that's like considered very impressive. Well, with this, like, yeah, right now the limit is 4 gigs. And that limit's just there because of the software, right? It's just what we can render in Vulkan right now. But, right, it could be more, right? And that's without breaking a sweat. Not even to mention custom triggers, right? Because triggers have always been implemented on the FPGA. And even when I started this project, everyone's like, why aren't you triggering on the FPGA? You have an FPGA. And I'm like, because I'm a huge believer in like the kind of inverse pyramid of like how accessible things are based on like the skills required, right? Like software is like much more common than gateware, and gateware is much more common than like analog hardware, which is what I do. So being at that kind of tip of like the really weird niche stuff that right, like isn't documented anywhere. No one's going to tell you how to make a scope front end if they don't already have if you don't already have a NDA with like with the scope manufacturer, in which case, yeah, you work there, you know how to make a scope front end, but you can't tell anyone. So I wanted to take that like very last bit and make something really robust, right? Like the front end on Thunderscope right now is actually massively overkill for the sample rate, and you can do some cool stuff with that. But the reason I want to make such a good front end is so a lot of people can use it for their applications as well. And we've had lots of people in science, in like all sorts of different fields, actually going, oh, actually, I need a digitizer, right? And why, pay NI like infinity cash basically to like get some fancy digitizers when you can just build one yourself? Like the ADC, the FPGA, that stuff is difficult, yes. But if you have an analog front end that's there, that's ready to drop in, then that becomes so much more doable than if you had to design a custom analog front end. So that's what I see as my contribution to this.
Sure.
And then it all goes up. So with triggers, instead of being stuck at the gateware level, right, which is how it's always been done, right now, if you know like high level code, right now it's in C#, there's a Rust version as well that's coming up. If you know one of those languages, you can basically say, oh, I need a protocol trigger for some weird exotic protocol. Well, what's a protocol trigger if not just a series of the right edge triggers and then the right amount of delay? And if it matches that, well, there you go, trigger. And that's something you can do. We basically can construct triggers from more simple triggers. And right, you can basically do whatever you want on your computer with a relatively more common skill set, rather than digging down into the gateware, flashing the FPGA, and all of that. So I think that's another huge step forward. And now more common is like open protocols, right? Like Salier, I think, lets you write custom protocols. I'm not entirely sure. Picoscope has like a APK or something for that. That's like relatively more common because that kind of post-processing is more commonly done on the computer for other USB scopes, not for benchtop scopes. That's still all in the box. But I think what really makes it powerful is that with NG Scope Client particularly, like all those protocols are already there. Like almost all of them are already there. And there's already like a framework for you to make those protocols as well. So you're not, dumping a CSV and then running it through some weird script to decode your custom protocol, which is a very common workaround for these limitations. You can just write the protocol decode, right? Push it. I'm sure Andrew's going to take a look at it and accept it, and then it's there for everyone.
Yeah, that's wild. I don't know which direction to. I've got so many questions for you. Well, let's start with. Let's continue on the hardware vein. Okay, I've got a question here. So, what's important about Thunderbolt in this project? Can you talk a
Yeah,
little
so
about that connection?
yeah, it's because it's really really fast. That's Thunderbolt slash USB 4 because USB 4 rolled in some Thunderbolt stuff, and really when I the reason it's like, oh, it's Thunderbolt or USB 4, fundamentally what it is it's PCIe encapsulation. So what you do is you just take a existing PCIe link and transparently put it through USB-C, and that's really really useful because that transparency lets it act like the PCIe card, right? Like there's no difference to your computer if you have Thunderbolt or USB 4 with PCIe encapsulation between this guy and this one here, because it just looks the exact same as if you plugged it in to a PCIe connection. It's how external like graphics cards work as well. It's really really useful, and PCIe gives you direct memory access, so you don't actually have any overhead copying things over. It basically the way PCIe works, and that direct memory access is so powerful, is you can basically say, hey, I want you to start filling up the data in this memory over here, right? You as the CPU. And then you get to look away and do literally anything else. And then you get hit with an interrupt that's like, yep, I've given you this data. It's over there. And you just go take the data. That's it. And that is really cool. And there's a lot more work to be done with the PCIe stuff. It's really exciting. Right now, we have 2 gatewares with 2 different PCIe implementations and 2 different drivers. And that kind of diversity in solutions is really what I'm most proud of about this project. Like, instead of just me saying, yeah, we're going to do it this way, and this way, right? Like, I wrote the XDMA gateware forever ago. Now there's LiteX. Now there's a LiteX gateware, right? And actually, if you just scroll up to, I have a diagram of all the different
Let's have a look.
projects that we rely on.
Here.
Yeah,
These
right
ones.
there.
Yeah, here we go.
And
Nice.
yeah, like as you can see, there's branching paths everywhere, and yeah, it's really cool. It's an open R&D effort, and
Yeah.
really, I think this is not just really useful to make Thunderscope happen.
Oh, dope!
It's
I didn't know
also
that White Quark was involved in this.
oh yeah.
Oh, cool.
Actually, yeah,
like open source hero for real.
yeah, Catherine's been a crowd supply alumni as well, and
oh yeah, I know.
yeah, absolutely.
Catherine's done a lot of really awesome stuff in the community.
Oh yeah. and that's the thing, right? It was really really cool seeing her work on Thunderscope RS, because the thing that I most admire about Glasgow, and the thing that I see every time people talk about it, is, hey, I just picked it up and it worked. Like, I just used it. There were no problems, right? And that's something I really, really want for Thunderscope. And in a matter of fact, that's why I'm committing to funding both the Thunderscope RS project and also Scope Client, because I think there's space in 2 different realms of users, right? Like having something that's completely frictionless for people, like maybe Thunderscope's your first scope, right? Maybe you don't need to decode USB right off the bat. It's going to be so nice having something that has that kind of like very, very accessible, very usable mindset. And then on the other hand, Scope Client, with the power that it brings, is a little harder to get into. But if you do kind of bridge that gap and get into it, you can do some crazy stuff with it, right? Like multiple FFTs, there's RF stuff. You can connect to multiple instruments from different vendors, basically make a whole test setup in Scope Client instead of having to automate it in Python or whatever. So 2 like almost different ends of the spectrum. And I'm just so happy to have both solutions available to people who buy Thunderscope. Because again, I see this as my role here is to make the best possible hardware, because when I ship that hardware to you, it's not coming back, right? And that's why it's been in pre-launch for 3 years. And that's why I've had 3 years before that to figure out the basics of scope front ends, because I wasn't comfortable with launching the campaign until I saw a path to shipping that rock solid hardware, right? Hardware that I'm proud of. And and I think that that particular section of the campaign page is what I'm most proud of. Because really,
I mean, I do want to come back to talking about your community and how you've developed it, and how open source hardware has played into all of that. But I'd also like to ask about what your progress has been since the last. What have you been working on? You said that you took a long time to get to launch. So why now? Like, why have you finally decided that now is the time? What has changed that makes you feel comfortable in your hardware decisions now? Is it, and are there community aspects to it as well? Do you feel like you've gotten enough groundswell to be able to launch? I'd be interested to hear your thinking behind all of that.
Yeah, it's actually interesting. I didn't come up with some, grand scheme or anything. I'm standing on the shoulders of giants.
As are we all.
And again, I'm going to also shout out Hackaday SuperCon.
Oh yes, you're going?
I am going.
Amazing.
So,
see you there.
Oh yeah, it's going to be so fun. But that's the thing. When I went for the first time in person, 2022, Carrie Sundra.
Carrie Sundra, yeah.
Okay. I was terrified of picturing
last
her
year.
last name.
She did a really popular workshop on workshops.
Oh yeah.
And actually, in fact, she'll be on the stream next week or the week after.
Really?
I forget.
That's incredible.
Yeah. We're going to talk about making hardware events. Yeah.
So she did a talk at SuperCon 2021. Sorry, 2022. 2021 was Remoticon, but 2022, that was fantastic. Like I remember seeing that talk and I was just like, well, there's my game plan. And the talk was on getting from like 1 to 100, right? And basically the first step was you build a prototype for yourself. It is the most janky thing on earth and you're just trying to get it to work, right? And then after that, it's like, okay, I'm going to build like, 3, 4, something like that. For me, it's 3 because Oshpark gives you 3 PCBs. So that's what I built.
And the story. Shout out Oshpark.
Yeah, shout out to them. You'll notice a particular shade of purple on these. So yeah, it was basically stuck in like 3 PCBs for like 3 people who are very close to the project. Like our long-term contributor, Mark, who I need to give a very specific shout out to, who's been fantastic. He's had every rev since Rev 1. And that's the thing. Up to Rev 4, there's 3 of them. And Rev 4 is when it really started to look like, yep, like this is ready. And that was on to the next step that Carrie talked about in her talk of do a beta run, right? Like you need 10 of these, right? You need to figure out what it's like to actually, assemble them, distribute them, have people, use it for the first time and see what the friction points are. And that was an amazing experience, right? Building 12 of these to as close as possible to production standards was eye-opening, right? Like I figured out how to do the custom enclosure, right? Like I'm also very proud of the packaging for this thing, right? I love me a Pelican case. And
who doesn't?
This case is custom foam, right? And I had to figure out, oh well, how am I going to do the foam? How am I going to do the packaging, right? And then in there's an accessory compartment. You actually lift out this thing that holds the unit, and then you'll see that there's also that's where your quick start guide's going to be, right there. And then you have a spot for your probes and everything, and like. Right. Like, I think it's a pretty thoughtful design for people who are going to actually be using this. Right. Like, I don't want to just ship something in packaging that's going to be thrown out. I want it to be useful. And that's why the PCIe card comes with nothing, because you're going to install that in your desktop and that's going to be it. Like your desktop's your scope now. And, if you're lugging that around, then, I'm sorry, but you're going to be lugging the whole thing around. Right. So, that's why you get the card. And for this, it's portable. So that's why you get the case. And that took a long time to figure out. Oh, yes. That's the link.
That's the link to the talk that
if you were thinking of doing a product, that was fantastic. So basically that's those are lessons I had to learn building 12,
Mm.
right? Because I didn't want to just ship them in like little ESD bags. I want to ship them for real. And that took a lot of time. That and like every bit of hardware you put on something. We use these modules now, right? So these are going to come down on the main board for the next rev. Same schematic design. It's just going to have to be routed. But you see, for beta
I'm
at
gonna
least,
spotlight you.
standoffs. Yeah. So you see there's standoffs there, right? There's standoffs, there's screws, there's nuts on the back, there's a custom PCIe bracket, right? All those things I had to make, right? Like I didn't, obviously for a run of 12, I didn't have volume to go anywhere. So I just machined these myself. This extruded heatsink also just machined myself.
Oh, wild. How did you do that? Where did you access those machines? Or did you get them sent off?
Well, that's the thing. I don't have like a CNC or even a manual mill.
Yeah.
What I did is just like really cheeky sourcing. So I looked through DigiKey and they do have heatsink extrusions, right? And I saw there was one with these little like edges that didn't have fins on them, right? Like there you go.
Put your hand in front of your face, it will focus on the hand. Yes, there you go.
There you go. That's a good trick.
It's a beauty blogger trick.
So yeah, it has this little edge on it, right?
Yeah.
And I looked at it and I saw the specs and I'm like, oh, that's actually perfect for mounting to this module. So I did that. I just took a drill press, gave it the 4 drill hits, did a little countersink, and then for the extrusion, it comes in this like big long extrusion, right? So I just took like a chop saw to it and done.
So it was an edit.
Pardon?
You edited some existing hardware instead of getting it manufactured.
Right? Like I didn't do it from
That's a
scratch.
really good
It
tip.
was just and I highly recommend that for like I understand the appeal of going full custom, right? Like, oh, I'm going to CNC it, I'm going to do full custom, but just using off the shelf until like you literally cannot is the way to go, in my opinion. Because again, like these,
I think that's a point that a lot of people don't get. Actually, this whole editing of things that already exist. You don't necessarily need to do injection molding for your first try. Maybe you could try designing to an enclosure, or like using something that already exists that will give your project polish is far easier than trying to do something from scratch. So I think that's something a lot of people don't understand. They think they got to jump straight to custom builds. So thank you for
it's the Apple effect, isn't it? Right? Like everyone wants to be Apple, right? And that's the thing. You can get very, very close and not have to do all those things, right? Like I quite like the way this one has turned out, right? So this the enclosure is an extrusion, right? It's already, it comes like this, black anodized. And what I did is I just took a simple diode laser, right? I don't have like a fancy laser or anything. It cost me about 200. The enclosure was a self build. That was a whole thing. Because I want to vent off, all the fumes.
We got to talk about the enclosure. We definitely have to talk about the enclosure. Like the last update was hilarious.
Oh yeah, well that's actually what you're seeing here. Like I have the little bezels on there, so you can see I've got these little bezels that a buddy of mine, Randy, 3D printed.
What beautiful bezels!
And that's the thing. I'm basically going to get these 3D printed in TPU. To stop it from wobbling around. And I actually had a great conversation just like an hour ago with Matt Liberty of the Jewelscope. And we were talking about how to do these bezels, right? How to use an extrusion to like the best effect, basically. So that's another thing that I've just been blown away by. I've had so many people contact me and like they're so willing to share their knowledge, and it's really wonderful.
Did you happen to see Carrie Sundra's last talk? I'm trying to. It was at Teardown. Wait, was it? Yeah, it was a talk at Teardown. This last one. She gave a talk about using 3D print farms.
Oh no, I have to check that one
again out. Really, Carrie is the holder of some legit knowledge for small electronics runs. And she gave a talk about 3D print farms. And actually, after Teardown last year, I think Carrie actually led a small group to go to one of the farms that she uses outside of Portland. So if you're thinking of, I think it's only a 20-minute talk, so I'd definitely check that out. That'd be cool.
Nice.
Yeah, very cool.
So essentially, like you can get most of the way there, right? Like another trick is using PCBs as Endcaps, right? Like
love it.
So with Endcaps for these things, I've got to do the
beauty blogger trick. Yeah, there we go.
Product. Yeah,
exactly.
So with PCBs as Endcaps, you actually get a lot of different steps that would cost you like a decent chunk of money, all in one. Right? You get milling, you get 2 different colors of silk screen, right? Like you can use, your regular silk screen. You can also use like the ENIG plating for gold or what have you.
There's all sorts of fun tricks you can do.
Diffusers for LEDs. That's what's in there, right? So you can do all sorts of stuff with that, and it's so cheap too. And it ends up looking really great. Once you cover the exposed edge like this, it's even better. So that's basically one recommendation I have if you're starting a product.
On that vein, there's 2 other recommendations. So 2 other projects to check out who've done that as they've done. So Bunny Huang, who needs no introduction, obviously, here's like the precursor uses a beautiful PCB as its front plate, and it's got like the antenna in there, all sorts of fun things. It's a really cool use of a PCB faceplate. The other one that I saw that was done super well is Nick Poole, who works for SparkFun and did a campaign with us here for an SMD cut reel parts counter called Bean Counter, and he used a sandwich of PCBs, and it was just chef's kiss. All the things that you're talking about, like using the diffusion panels and then the cute little layer of 3D printing around the edge to hold it all together. It looked so slick, and it was just PCBs. So I second that recommendation.
Actually, I'm just aghast with the fact that I have stories. Again, more and more crowd supply alumni have struck this this conversation because Bunny actually he sold me the FPGAs that I'm using for this first production run.
I know.
Which
I've
is,
forgotten
again,
that
wow,
though.
Small world. And
this was the desperate days of this chip crisis, where it was really like people were reduced to begging for chips on the internet. And I've forgotten the fact that
other
Bunny
lesson
sorted
learned.
you out with your
Don't preemptively source anything. All right, don't panic. Right, because I sourced almost like all the major components for this thing in 2022. And I was like, it's because I'm going to launch soon. Right. And no, right. I could have sourced them now, but it was good motivation, right? Having that giant Pelican case full of components. I was like, well, I got to build it. So yeah, that was one story. And Nick actually wrote a great guide on how to do these Snapoff tabs. Right. So on the top of, there you go. So on the top of this Thunderscope unit, I use actually 2 different series of like Snapoff tabs. Right. So this top rail exists for the PCIe version.
Oh, right? I see. Yeah.
And then on the other side, you'll notice here, especially, right, these little bumps.
Yeah.
That's basically the same Snapoff tab that exists for the Thunderbolt version, because that allows it to just kind of slide into the extruded enclosure. So that's how I basically mechanically make this one PCB work for both options. And he wrote a guide that was like very, very like meticulous as to how to get just the right breaking strength and everything. I believe that one was published as a blog under SparkFun. So check that out if you find yourself in need of tabs.
For those
also, I noticed
who are watching
Timon
this afterwards, we'll put that in the show notes.
I'm just on a roll
actually,
here.
There's some good stuff here. Like, hey, wait, so hi, Timon. Also,
there you go.
And Timon's also said, I think anytime you don't interact much with the device itself, the path to off-the-shelf enclosure options is always smarter. If there's not much UX involved, no real reason for fully custom designs. Now, Timon knows a lot about product design and is a source of information here. So, we definitely believe you. Thanks for that, Timon.
Actually, I also have to give him a shout out for his M.2 footprint library that I used for the accursed adapter. That I connect the little Thunderbolt adapter to the main board with. He actually has a library for those like M.2, the little edge connectors. So I just yoinked
Nice.
that, and I'm like, well, I'm gonna have to give you a shout out for that, because that saved me a lot of pain. So yeah, there you go.
Yay, that's delightful. Good. This is a good segue to talking about community involvement. Okay, so your community is very enthusiastic about you, and I know that you talk about yourself as a hardware EE guy and rather than a software person. And I would really like to know, first of all, this is a great opportunity to shout out all of your software dev community and also tell people where to go to find a path to contribution as well. But yeah, I just really would like to talk to you generally about how you found that community, how you built that community, how you're managing that community as somebody who is less of a software-y person, and also what possibilities that community has opened up for you as a hardware developer. That was a lot of questions in one go, but
yeah, I'm
they're
gonna
all in
try
the
to
same
answer
vein,
them
so
from
go
like
for it.
start to finish, but like I'm not sure if I remember the first one. But anyway, yeah. So the actually, I genuinely forgot the first one. So what was the first one?
It was just about the influence that so how you created how this community came about.
Oh, yeah, actually, shout
Yeah,
outs. Could you
yeah,
please
shout
just
outs
put
as well,
that
definitely. Shall I put
diagram
the
back on the
GitHub on?
screen?
Oh no, yeah,
No,
I can
just
do
the
that.
diagram.
I can do that.
We're not going to go through all the GitHubs because like there's a lot now. I also have like a full list. Actually, you can look at the diagram. This is just the brief. Everyone is credited there, right? So I just want to thank everyone who's helped out with the project. There are again many different paths here, and it's just been a huge learning experience as to like how do you make a scope, right? And there's just so much to it, and yeah, it doesn't end at just the hardware, right? Like I've been involved with the development of a lot of these different things because a lot of the software does need to talk to the hardware, and it's like, oh, like how do you change the like digipot on this path? And I'm like, oh, okay, like I'll tell you how to do that. It's this and this, right? These registers. And yeah, it's just been incredible getting to work with all these people.
And how did you find these people?
Oh, that's a long
Did you
story.
just publish it? You didn't. Well, this is it, because I think people. Oh, hello, hello.
Oh yeah, there's that so AEW 2015, that's FPJ Zealot. He actually reorganized the whole XDMA gateware so that you can just build it with a script instead of like, you know, going into Vivado or doing all this stuff. And yeah, it's a lot easier to edit it now because everything's all in like one place instead of just being 4 separate projects that you also have to open up in Vivado. So that was a huge help, just making something organized, because that's the one thing, because I do a little bit of gateware, right? But I'm at that level of competence where I can write it, I can make it work. But that kind of knowing how to refactor it, knowing how to make it nice is that's not my skill set. But again, the beauty of having a community of doing something open source is that yeah, like Andrew, FPJ Zealot, came by and basically went like, oh yeah, I know how to do this. I do this all the time here, and contributed it. And now, yeah, every time I change the XDMA gateware, I'm like, oh, this is so much easier. So yeah, that's one of them. And yeah, I just want to shout out everyone there. There's yeah, it's just been amazing getting to work with everyone. And the most important thing I have to say is, I believe if you're selling hardware, you're in the unique position to give back, right? To all the things you rely on. And right, like, why is it that me just, you know, I've built the hardware, yes, but by building the hardware, I also end up selling the hardware. And like, it just doesn't feel right to me to be like, oh, I'm just gonna like, you know, take all that and make more hardware. Sure, like that's fine. I will be making more hardware, but I just don't think that's sustainable. right? Without
Well,
really
it's a
giving back
very
the information.
interesting point in that people are willing to pay for open source hardware in a way that people are not willing to pay for open source software.
Exactly. I've had
And
great
not
conversations
that, you
about
know,
this.
open source hardware is exactly a path to riches, of course. I'm not insinuating that, but there is a conversation to be had around how we financially compensate our open hardware and open software creators in order, because as
Exactly.
you said, I mean, look at this tree. We've got hardware, gateware, PCI. You know, there's so many different aspects to it. Hardware isn't just the PCB. Well, there's been
Exactly.
lots of
I
drama
think
over the
that,
years based on this, but
oh, I can only imagine. But like that's
yeah,
what we need. We need solidarity, right? Like
it's
if I'm
true.
designing hardware,
Really
right, I want to make sure that like
true.
people can develop the software sustainably, and I'm going to
Mm,
do whatever it takes to make that happen. Because yeah, I am in that position of actually selling the thing. Um,
yeah.
and the way I see it is if you're buying open source piece of hardware that relies on such a huge open source software stack, then you know your purchase is a mandatory donation to the software, right? And yeah, I think that's a great way to do it. Because right, like if you design a good enough piece of hardware, especially with something like test equipment, right?
Mm,
And
mm.
I can get into clones as well because I don't care if this is cloned, right? Because what you sell when you sell test equipment specifically, we're in a very good position for that, is trust, right? The
And
reason I'm
support.
out there, right? Yeah, and support, right?
Trust,
The reason I'm
support,
out
and
there,
also there's something that people forget is like access to markets here. Yeah, sure, you might be able to clone something, but having distribution and having the correct execution is also a USP that has nothing to do with proprietary files, you know?
yeah, yeah, right. And that's the
And I
thing.
do agree with you. Yeah. Yeah.
Like making sure that like yeah this thing if you buy a Thunderscope from Avengers, you are going to get something that is built with the correct components, that comes with calibration, comes with support, and right, like you can do all of that, all those value adds that make
Mm,
a scope a useful tool that you can trust for years and years to come. None of that involves hiding the sources, right? Like that's not there, right? The work that goes into making it a reliable instrument, a lot of that is not design work, but rather
no.
all the other things,
Execution. It's
right? And the
execution.
software as well, right? Like the
Well, yeah,
idea is to make the
absolutely.
software a joy to use and a way to accomplish something that you otherwise couldn't, right? Because there's so
Yeah.
many pain points with like traditional benchtop scopes of, oh, well, I could do this, but I have to pay $500 for the license to do it, right? So you
There is.
end up again,
Yeah.
export a CSV, you run it through some script or whatever, right? And like again, I have so many qualms with the test equipment industry. You sell me a scope, right? There's a base model of this bandwidth, and you know the base model is like $500, and then oh, like the top model is like $2,000 or whatever, and it's just a bit. You're flipping like two bits.
It drives me crazy. I really,
Yeah,
really dislike this. I have a scope on my bench right now that is pulling this, and it makes me want to throw the whole thing out of the window. It's like, don't let me own my hardware, please. Come on. Like
the
I
way I
bought
call it
this.
is
Like, let me
they're
use it.
holding it
It's
for ransom. That's literally
exactly.
what it is. They're holding
It's
your own hardware for ransom,
It's
and I don't want
hardware
to
as
do
a
that.
service. It's like this VC software as a service nonsense is
Oh, just wait until they
infecting
do like
hardware,
actually they
has
already do
infected. It
subscriptions
drives me.
for high-end
I know,
scopes.
I know, I
You have
know. My
subscriptions.
car. Come on now. It drives me crazy. It
Oh,
drives me
that's
crazy.
nuts.
Anyway, so
So yeah, and that's the thing, right? I really think
oh
like and that's the theme. I'm looking to make something that is just clearly better, right? Like
yeah.
I put so
Yeah.
much effort into being able to say, yes, this front end has specs to match, right? Like it is as good or better than any other scope you'd compare it with, right?
Yeah.
I put in a lot of work on that, right? And then on top of
Clearly.
that, the openness allows you to do these kind of extensions to really own your own scope and not have to worry about, oh, I need to run the keygen and unlock it or whatever, right? Or dump all the waveforms so I can analyze it. It's like no, it's all there, right? All those friction points of these closed source products aren't there. So yeah, I think it's not just from a technical hardware level, but also from a software level, I think this is just a better solution.
Got some comments here from Timon says, nobody knows your design better than yourself. Just that institutional knowledge is very important to manufacture the hardware correctly and not make mistakes with bad part substitutions or the PCB stack up, especially for high speed stuff like this.
Oh yeah, the custom stack up, like the FPGA modules on TU-872, if I recall correctly, which is not your standard FR4 material, right? Again, a second shout out to Oshpark. Oh, I know Drew's in the chat here, so using FR408 for 4-layer and 6-layer is great. That's a fantastic substrate. And again, that's why I use Oshpark versus going somewhere else, because like you're just dealing with regular FR4, which can be anything. And then as soon as you actually like ask them, oh no, I want FR408, or again, TU-872 is kind of the equivalent that's more common over there. Yeah, that's where things get pricey again. And at that point, yeah, I'll just order it from Oshpark. So also 6-layer Oshpark, very, very good. We really need something that's for like really high speed, really tiny kind of things. Maybe an 8-layer service, please. So that's my public plea. I'm begging you.
Yes, that's hilarious. That's hilarious. I've also got a little bit of insight here. As so Keysight says companies prefer to loan instead of buy for tax reasons. Right. Yeah. I got it. I got it. Yeah. It's just annoying for the user, I guess.
Yeah. Well, if they choose Thunderscope, which again comes in this conveniently NI digitizer shaped package, then you don't have to loan anything. You buy this thing and you're done. Right. That's everything. And
talking
you
about
can chain
buying
them
this
together too.
Oh, you can.
Oh yeah, that's the idea. This little port,
wow.
You plug them in, and you can just be like, "Oh, I want 8 channels." You chain it together.
Nice.
Yeah, cool. Actually, here, let me show you the little port there a little bit better.
Whoopa. Oh yeah, I can see it. It's still trying to focus on your lovely face. There we are. That's better. There we go. Nice.
Quiet for a second, right? And that's what these ports on the back of the other model are as well.
Oh, I see.
Right? You can see that they're.
Yeah, I see that. Yeah.
Yeah, nice. So we actually we haven't implemented that in Gateware. Ng-Scope client already has a utility for synchronizing these things, so it shouldn't be too many more steps. But that's on the docket. Nice. Again, the point of the hardware is to just be as flexible as possible. So I've thrown in so many different things onto the hardware that is like, may not be there now, but the idea is it's a scope that gets better with time, right? And, at the beginning, it's going to get better a lot faster because those hardware features are going to be unlocked. But the thing is, eventually you'll upgrade your computer and then your scope gets better too. So.
Got a question in from Kushal saying, how many could get chained together? Could you get 60 in the channels?
It's going to be murder on your CPU and GPU, but with the PCIe cards, it's going to be a lot easier. Like the BNCs, you could do some T-joint adapters. It's going to look pretty gnarly. Those like 8 channels are a lot easier for that. But with the PCIe, this particular adapter, the cables for those are commonly used in multi-drop configurations. They're insulation displacement connectors. So you can basically just get a connector that hops over from one card to another, fairly easily. Like I already bought one of them for like a 3-card setup just off of DigiKey, not even like a custom thing. So yeah, like that's the idea.
I'm sorry, who?
To do that. Oh, sorry. I mean, Mouser.
I'm only joking. I'm only joking. For those of you that don't know, Crowd Supply is owned by Mouser Electronics. So I'm just messing with Aleksa. And Shu, hi Bob, nice to see you. I hope you'll be at SuperCon. A scope that gets better with time, literal scope creep, but in a good way. I like it. Very funny, very funny. We're nearly an hour in. We're 50 minutes in, no. and I have not yet. Let me just do one thing. Hang on, mate. Congratulations. You have smashed your total by some way. You've raised over $250,000 for an open source oscilloscope.
I can't comprehend that.
I'm gonna say this has exceeded your expectations, right?
Oh,
Like, can we just talk about this? Can we just talk about this for a moment? Like, yeah.
I mean, I'm just glad. Honestly, like, it basically hit the goal, and I kind of just looked away. I'm like, hey, I'm doing this now. I actually, one big thing is I'm working full time on it now. Like,
Wow!
I'm full
Congratulations!
commit.
That's a big
Yeah.
step.
And I can talk about working full time,
Wow.
like working full time for yourself. Like,
I mean, I've done it. I've been there.
Oh yeah. The thing no one tells you about is like, you're like, oh, I can make sure that I just get the right amount of work done. And turns out, no, you'll just always blame yourself for not doing enough work.
Oh, absolutely.
So
I did
have
it for
to
10
be
years.
careful.
Like, it is, it's
so
tough in many, many ways.
The whole thing. I'm still learning.
Yeah.
I'm still figuring it out, but
you're doing a great job, mate. And like, there's lots of us cheering you on as well. I'm very excited
thank you so much.
I'm very excited to see that it's finally coming to fruition, and I'm also excited to see that the community is rallying around it as well.
Yeah, and that's the thing,
a long way.
I just cared about getting to the goal because that's what I knew I could build. And the way I see it, the higher this gets, the more we're going to be able to fund the software projects we depend on. The better Scope client is going to get, and we're going to have a whole new like oscilloscope client out there, like with TSRS, because like knowing Catherine, it's probably going to end up working very well with other scopes as well, because it's well written and anyone can hook into it because it's completely open source. So it's just so exciting. I'm trying not to get too excited by envisioning what the future holds, because I'm focused on building and shipping these things. Hopefully beating the deadlines too. Yeah, that's about it.
Well, I mean, you've got to let yourself feel some excitement. Otherwise, you're not going to carry yourself through all the boring stuff, right? Unfortunately.
Oh, I have had to do so much paperwork.
I know. At a certain point, there's just a lot of contracts and emails and a lot of writing,
emails too, vendors everywhere.
Yeah. I mean, it's wild, truly. It's really isn't just the hardware. The hardware is like a very fractional part of actually getting a product to market. There's a lot to think about, and not all of it is interesting.
That's the thing. Everyone sees the glamorous bits of like, I designed these circuit boards. I'm working on making the thing better.
So tell me what part of it is your least favorite? What part of it you're like, oh my goodness, I've got to do these forms, or oh no, I've got to update my Discord, or whatever. Like what is what are the parts of doing it that you don't fill you with joy?
Actually the hardest thing for me is writing. Like,
really?
I can do this kind of conversation all day. Don't try me.
You're a very chatty person. I like it.
I am. But
it's easy to do a stream with you. It's great.
Yeah. But putting your thoughts into writing, that's difficult, because like I've got all these thoughts, so very, very many of them, and like putting them into writing is hard. So doing like the updates, doing all that, like my crutch for that is just like the update looks like a picture book, because I'm like, hey, like I want to show you the cool thing I'm working on. But yeah, like long form writing is a challenge for me.
See, that really surprises me that you'd say that, because you're such a storyteller. And if you look, if I go to your GitHub, like right now, where I'm pretty sure I've got a tab open somewhere. Where have we got? Here we go. Look at this. TSOS. This is your GitHub for Thunderscope, and it starts.
Don't embarrass me. That's my little pet project.
Time. Like this isn't embarrassing. This is very human, and it's enjoyable to read. So it really surprises me that you say that you struggle to communicate by writing, because that's seriously not the impression that I get.
Thank you. So. Maybe I'm just too formal. Like maybe every time I write something for Thunderscope, I'm like, I've got to be correct, right? I've got to be like, very even keeled. Well, when I do something personally, right? Like I've been thinking of doing a lab journal of all the other random stuff that I do.
Do you follow Joey Castillo? His journaling, I don't know if you call it journaling, but he's an amazing writer. I'd say he's probably, him and Bunny are my favorite writers in the open hardware universe.
He did the description of that one inductor that he had. Like, it was something like 13,000 microhenry, right? And it had to be this tiny inductor. Like, that was a wild ride. So that was a great read.
Yeah,
Also, shout out to him. Huge part of how I like actually came up with the pricing and did all the spreadsheets was inspired by his talk at
Teardown
20,
which was not published. That was one of the ones we didn't publish.
Oh yeah, sorry.
No. I mean, and I'll explain why. No. I'll explain why. So one of the things I really rate about Joey Castillo is that his approach to open hardware isn't just releasing his files. It's also about talking about all of the other things. He's very open at talking about all of the other parts that go into it. You know, he makes out in the open, right? But he also did a talk at Teardown last year, which was just a complete opening up of all of his finances, who he's getting paid by, what margins there are, all of the different costs associated with business and all of that kind of stuff. And I thought that was super cool of him, but he didn't want them published on the internet, which is understandable, I suppose. But yeah, it was a great talk. Another person who's done a bit of talk, who did a decent talk about that was Ben Hank, and that was from not 2024, but 2023 Teardown. And he did a 15-minute talk about that. Yeah, but I do, that Joey's talk was excellent. I'm glad you benefited from it.
Oh yeah, and we had a long conversation afterwards about it, and like, yeah, it's a hard thing. Like, pricing your product is a hard thing. Obviously, like, you know, knowing how I've been conducting all this, I want this to be as accessible as possible, right? So you've got like the angel and the devil on your shoulder of like, hey, you need to make rent. This needs to be higher, and hey, you could make it lower.
See, now I feel like that is false, actually, because it's not. When we're talking about sustainability of open source hardware, we also have to consider the people making it. And unless it's paying your rent, it is not financially sustainable in the long term.
As I say with the software people, right?
Then what unless you're magically rich, then who's going to be making the open hardware? So I do actually believe that it's okay to make a living. I'm not talking like a killing, but like we should be aiming to let open source hardware creators make a living from their work. Otherwise, what are we doing?
It's that weird thing, right? Of like, I can suffer. I can be like, it doesn't have to be that high. But having that commitment to 50% of the profits going to the community, it's not just me, right? And that's why I was like, okay, we need like an actual margin that is sustainable, because I need to make rent, but also I want to make sure that this can continue with the software as well. So it was really enlightening.
It's about it having legs. You know, it's about it not just being one shot, because if you're working nonstop and not taking any other projects for a year and then you come out of it and you're broke, then how are you supposed to be able to do the second revision? You know.
Yeah, exactly.
So
also,
I mean,
just a quick break. Timon, I just want to say, yes, I feel that, and he also had a comment earlier about maybe being able to use the software. So
yes, that's fun.
Just like DM me or something. Very happy to talk about that. Like I think this software, this hardware product is the one thing, and what I want to do is, use that effort to make other things possible, right? Like, more people can use this host software, right? Scope Client's a long-standing project. You can already use it right now with your scope, maybe, if it's compatible, or play around with the demo scope, right? And like the drivers as well. If you use LightX, they only had a Linux PCIe driver. Now we have a Windows driver and a Mac driver in the works. Right. And that's because of contributors that I guided over to.
Is that White Squawk again?
No, those are actually Nate and Sabrina for Windows and Linux, respectively. Sorry, Windows and Mac, respectively.
So Timon says it's not a scope, but also in the test instrument realm.
I'm always excited about open test instruments. So yeah, that's going to be pretty rad.
Saying $1,000 is very affordable for the level of hardware being delivered when compared to what's out there, even from Picoscope.
Yeah, Picoscope was Picoscope were who I was like going after with this, right? Like I remember looking at them a long time ago when I was looking for a scope, and I was like, I love the idea. I really love the idea of like a computer connected scope, like all of that. And then I looked at the price tag and I was like, oh, okay, that's not for me. So yeah, I wanted to make something that was, you know, more accessible to, again, basically me when I started, right? Like this was going to be the scope that I I would have wanted to have when I started out in electronics. And I really think like, you know, if I teleported this back in time, like when did I start? Like 8, 9 years ago. Uh yeah, I would have been completely thrilled. But I wouldn't be able to use it because Thunderbolt 3 didn't exist.
Oh, wow. Well, future you can use it.
Yeah.
All right, we are at an hour, so we're officially done. However, I did want to make sure that anybody in the comments, there's quite a few of you here today, if you have any burning questions that you would like to pose to Aleksa, now is the time. And
or you
Aleksa,
can join the Discord and ask me at any time.
I was just about to say.
Oh, okay.
Would you like to share anywhere? Would you like to share where people can get involved with the community and ask you future questions?
Oh, absolutely. Again,
how does one find your Discord?
You can find it from the GitHub. You can find it from the crowd supply. You can find it from anywhere. You search up Thunderscope and it should be like one more click away.
Yeah.
And I'm not going to get into the discourse about Discord. You know, open source projects in Discord. It's a whole thing.
I know. And it's like
it is what it is.
Information on closed forums. Yeah. It's not.
But
it's
actually,
not great, but it's what
thanks
we got,
to Catherine, it is bridged to IRC. So if you're an IRC person, there are 2 channels on IRC connected to the server. Nice. One is for discussion specifically about Thunderbolt and USB 4, and the other one is for Thunderscope specifically. And those are also listed next to the Discord, wherever the Discord is listed. So at least there's some, you know, accessibility on that front as well, if you truly want to avoid Discord at all costs.
Catherine being an open source MVP as per usual.
Absolutely. It is a pleasure to work with her.
Yeah, for real. Timon says, I think the pricing is perfect. It's still in a realm where it's accessible for enthusiasts that get an entry-level wriggle or something. It's less work and you have a limited bandwidth. Go with what gets the thing done. I think that's a very good point. Thank you for making it, Timon.
Yeah.
All right. So do you have anything else you'd like to share with the people at home apart from go support? Oh, wait, that's a great thing to support. Timon says, go support White Quark on Patreon. Great shout out. That's a really good idea. Boop, boop, boop.
Yeah. You know, the XKCD comic where there's like the load bearing, like the one person.
I knew exactly what you were talking about before the words came out of your mouth. Like, that is very accurate. That is a very accurate description. I was like, yeah.
Yeah. Honestly, I think that's a good place to end off on. Like,
exactly. The end. You know, goodbye. Go about your week.
Support the people who make all these open source things happen.
Damn straight.
And like, I know, you know, as a hardware designer, I've already said my piece. I think, you know, I encourage that if you are making hardware, you know, take some bit aside and support the people that make your hardware possible, because there's no such thing as pure hardware anymore, right? And you know, a lot of people aren't full stack. I'll write everything myself, right? Me especially, right? I'm in that weird position of I don't code. I just don't, right? Like I'll dabble, but this is what I do, right? And I want to do the thing that I do really, really well, and I want to make sure everyone else can do the thing they do really, really well. And I think, you know, as a whole combined, we have a shot at making like really top quality oscilloscopes and, you know, in the future, other test equipment, and also supporting other people who want to do the same.
Amazing. Well, that's a great place to end it, Aleksa. Thank you so much for being an engaging guest as per usual. I hope to see you in just under a month, I guess, at SuperCon.
I'm excited.
Quite fun. I'm excited too. And I'm sure we'll hear from you again once you're close to delivery as well. I'm sure you'll come back on the stream. Now, we are back next week with so the next next week, on the 10th of October, I'll be talking with Carrie Sundra, who we've talked about a lot today, actually. Who is the person behind Alpenglow, all sorts of really cool electronics designs. And she will be heading off to Maker Faire in mid-October. And we're catching up with her just before she goes to take a look at some of the stuff that she's been designing. But we're also going to be having a conversation about hardware events and how to run them. So Carrie, as well as doing PCB design, does a lot of workshops, and recently did a really awesome workshop on workshops at Teardown. And of course, I run Teardown, and I also have started several hardware happy hours in London and Berlin, and now in Portland. And so we'll be discussing how we do that and how we get people interested and involved from the community. So that's what I'll be discussing with Carrie next week. If you are interested in that, I will see you here, same bat time, same bat channel. In the meantime, go support Thunderscope and White Quark on Patreon. And again, thank you to our sponsors, AMD.
And one more shout out.
Go.
Teardown. Fantastic conference. And again, someone here had the idea to run it in an old Gap, which was incredible, by the way.
It was such a vibe. Now, okay, so I do actually have, we don't have any news, but I'm gonna be indiscreet and tell you that I've been in touch with the Lloyd Center, because last year I was like, okay, the mall was such a great place to hold a hacker conference. It was so fun, pure vibes. But they might demolish it, right? They're going to demolish it. That's why we can get the space, for cheap. And they wouldn't let us book it for next summer because they thought we're going to, they weren't sure if they're going to demolish the mall or not. But it turns out they're not. So Teardown 2025 in the mall is on. I haven't signed the contract or anything yet, but hooray, the mall will not be demolished. So yeah, I mean, I'm hoping to bring some flyers and to SuperCon, and I'm also hoping to have the CFP open by then as well. But let's see how my month goes.
Awesome. Well, hey, thanks everyone for watching.
Fun times, yeah, for real. It's been a delight to hang out with you, and I'll see you all again soon. Okay, bye.
Bye.